Hello students, so today I'll continue with inheritance extending classes. So be sure to watch the previous videos before you watch this video. Okay, so let's discuss about today's topic. So in today's topic, I'll be discussing the programs which you find in your textbook. Okay, that is program on class inheritance to find area of triangle and rectangle. Okay, and using that same program, okay, I'll be demonstrating the base class constructor and derived class constructor. Okay, in your program, the constructor is not mentioned. Okay, however, uh, with the program that I've modified, okay, I'll show you how constructor is also used. Okay, so let's go on to the next slide. So if you see in the textbook, okay, this is the program that is been that is written. So the program is about demonstrate a sample example on class inheritance for finding the area of triangle and rectangle. So I've been stressing on the visibility mode, that is the access specifiers, private, protected, public, right? This is very important when we discuss about inheritance programs. Okay, if you understand these visibility mode, these access specifiers, private, public, protected, okay, then understanding these inheritance programs will become much easier. Okay, for that, that is provided you understood classes and object very well, okay, and constructors and destructors very nicely. Okay, so as you can see that inheritance program, okay, is just like the copy of the classes. You have multiple class, but how the main thing is that how the data is transferred from one class to another. Okay, that depends totally on the visibility modes. Okay, so if you see in this program, you have your header file, okay, and then under the comments demonstrating the class inheritance. So here you have the base class, that is class polygon, C polygon. Okay, so that is the base class name. So under the base class C polygon definition, you have the data members int, width and height of type int. It is under the access specifier protected. Okay, it is under the access specifier protected. So and then in the for the member functions, the functions that are defined here is void set values, okay, which declares the two parameters, that is int a and int b. And within the function body you have width has been assigned to a has been assigned, okay, a has been initialized to the width variable and b has been assigned to height. Okay, so the value of a and b has been assigned to width and height. So that member function, that particular member function has been made as public. So here the data members is the two data members, that is width and height, has been given protected access. Okay, if had it been given a public access, okay, then any of the class or any of the objects or non-member functions can also access the protected the public access, the public members. Okay, and had it been given as private, that is the width and height, then none of the class can access the private members. Okay, since here it has been given as protected, okay, protected means, okay, here as it is written here, the protected access specifier is similar to private. When a class inherits from another one, the members of the derived class can access the protected members inherited from the base class, but not its private members. Okay, so the protected members, or yes, in this case the protected data members can be inherited to the derived class, that is C rectangle and C triangle. Okay, but when it is being accessed or when it is being inherited, okay, that members will also stay as protected under the derived class. Okay, it is here, it is not visible, it is not mentioned, okay, but the access has been given as protected. Okay, so here under the derived class, uh, that is the class C rectangle. Okay, so the class C rectangle using the colon, okay, it shows that the class C rectangle is inherited from the C polygon class. Okay, and here the access specifier is mentioned as public. Okay, so which means that the derived class C rectangle, okay, has public access to the members of the C polygon class, which means that the public member functions void set values, okay, will stay as public. However, even if the access to the C polygon base class is public, okay, if there is a private data member, that private data member cannot be inherited by the C rectangle derived class. And here there is a protected that there is a protected data members, right? So that can be inherited by the C rectangle derived class. However, when it is uh, declared inside the C rectangle uh, definition, okay, it will stay as protected. Okay, it will remain protected even though the access is given as public. Okay, public C polygon, yet the width and height in width and height will stay as protected even in the derived class. Okay, so now why is it needed? Why does the derived class C rectangle, okay, needs access to the C polygon base class? Why? Because you can see that in the formula, okay, under the public member function in area, under that function body, return width into height. So width and height is not declared in this class C rectangle. Okay, class C rectangle has not declared any data members. These two particular data members, that is the width and height, belongs to the class C polygon. Okay, so since the formula is executed, they return width into height. Okay, so that width and height value, uh, or that width and height variable is declared in the class C polygon. Okay, so that's why the C rectangle needs access to the C polygon. So that's why it inherits the protected data members, that is the width and height. Okay, so that's why there is a link that is established between the derived class C rectangle and C base class C polygon. Okay, so only that through that way the class member function in area will get invoked, and it will execute the statement, that is the return statement, width into height. Okay, so similarly, uh, another derived class is their class C rectangle. Okay, so this class C rectangle is also deriving from the C polygon, and here the access specifier is also mentioned as public. Okay, so you will see that the class C rectangle is actually not deriving from the class C rectangle, but it is but it is inheriting from the base class, not from the derived class. Okay, so here in this particular example, we have only one base class and we have two derived class, that is two derived class C rectangle and C triangle. Both the derived class are inheriting from the base class C polygon. So this is an example of hierarchical, okay, inheritance, which we will discuss in the uh, next, okay, next presentation. So here both the derived class are inheriting from the same base class. Okay, so hierarchical inheritance. Okay, so here also you will see that under the public member function, okay, the in area, so the same function name is being used. Okay, but keep in mind that it has been declared under two different class definitions. Okay, so here within the function body, return width into height divided by 2. So here also it needs access to the width and height values, right? So that you can find it under the C polygon class definition. Okay, so that's why the derived class C triangle is inheriting from the public C polygon, though it is mentioned as public. Okay, yet the data members will stay as protected here. Okay, so when we come to the main function, okay, you can see that the class C rectangle and the class C triangle, okay, has declared two objects, as rect and rect and trgl, triangle short form. Okay, so the two objects are declared, two objects are created. Now, as you can see, as I've already told you, okay, most of the objects in inheritance, okay, will be declared from the derived class and not from the base class, okay, because the execution of the program will start from the base class and move on to the derived class, okay. So most of the program logic will be executed on the derived class, okay. So the base class just acts like a template, okay, for providing let's say providing the information, the members, okay. The base class only acts as a template to provide the members to the derived class, okay. So the actual execution of the program logic takes place in the derived class. That is why you will see that, okay, the when the objects are declared, the objects will belong to the derived class. As you can see here, C rectangle is a derived class, the object is being declared. C triangle is a derived class, okay, and the object has been declared. And as you know that when the object gets declared, okay, the constructors gets invoked. And you can see that in here in this particular program, okay, the constructor has not been mentioned, right? But even if the constructor is not being mentioned, okay, the constructor gets invoked automatically, okay. That will be explained in the next slide, okay. So let's just focus here on this current program, okay. So once the object gets declared, okay, then uh, in the object, in order to access the base class member function, okay, the object invokes that member function set values, okay. So using the dot operator and assigns the value 4 comma 5, okay, 4 comma 5. So this is an implicit call to the uh, uh, to the member function, that is set values, okay, in the under the that is under the class C polygon. Since it has been declared as public, the object can directly access the member function, okay, and then it assigns the value 4 and 5 to the parameter int a, int b, okay. Since 4 and 5 is integer values, so that's why the data type there is also mentioned as int a and int b, okay. So the object rect passes the value passes the argument 4 and 5 to the variables a and b, okay, and then the variable a and b, okay, a is assigned to the variable width and b is assigned to the variable height, okay. The return type is void, okay. So this function does not return any value back to the calling function, okay, back to the main. So that's why the return type is void. Then again, triangle dot set value 4 comma 5, okay. So again, uh, oh yes, then again what happens that is that value is again, okay, sent to the set values function, okay, and then it is assigns the value back to the width and height. So you get the same value again, 4 and 5, okay. Then after that, okay, the control comes back to the main function and to the next line statement, that is cout. Cout, the area of rectangle, is, okay, rect dot area, okay. So now this is the calling function, okay. So what it does is, okay, the object, okay, calls this function area, which belongs to the derived class, okay. So it calls this function dot area, which belongs to the derived class, which is in the derived class function definition, okay, and then it executes the formula return width into height. So now the value is passed, the value which is stored in width and height 4 into 5, okay. So it executes that and it returns the value 20 back to the calling function, that is area, okay. So in place of that rect dot area, that value will be passed, and then you will get the value cout, the area of rectangle 20, okay. So as you can see that there's a return statement, right? And that's why the member function area has the return type int, since it returns an integer value, okay. Another thing that you'll notice is here in the calling function rect dot area, right? You can see that parenthesis, right? because here that area is a function, it is not, it is a function, right? Okay, so that's why that parenthesis is needed. If you remove that parenthesis, that curve bracket, okay, you will get an error. Okay, so you can try removing that curve bracket and then check out what errors you get. Okay, similarly you can remove the values 4 and 5 under the set values, and then you check out what errors you get. Okay, then for next line statement, area of triangle, okay, triangle dot area, again it will invoke the C triangle, okay, member function that is in area, and then it will execute that program logic return width into height divided by 2. Okay, so since here also the return type is in, it will return the value back to drgl dot area. So you'll get the value, the area of triangle, okay, 10. So this is how you execute this particular inheritance program. Okay, so you can see here you have the protected public. Okay, so students, what you can do is that, okay, you can type the same program in your on your system, okay, and then just try changing the class C polygon, that protected access specifier to public. Okay, and then you can change it to private. So you change that to public, and then under the class C rectangle you try changing that public C polygon to protected to private. Okay, so try changing everything. Okay, class C polygon private, and then you can change that to class C rectangle private. Okay, you will see different types of errors that you get. Okay, so by that you will try to try experimenting like that. Okay, then you'll get much better understanding about the visibility modes and how the access is done from the derived class to the base class. Okay, so now let's move on to the next slide. So here you can see that in this table, okay, the access that is given to the different members, public, protected, private. So here, access to members of the same class. Okay, access to members of the same class. So under the same class, the members, okay, that be the data members or the member function. Under public mode, it is yes. Okay, then under members of the derived class, okay, members of the derived class, okay, when it is public, then it is also yes. Okay, it can have access, but non-members also, it can have access. Okay, so which means that, okay, when the access mode is public, the members of the same class can access it, members of the derived class can also access it, and non-members also can access it. When it has been set to protected, okay, members of the same class can access that. Okay, members of the derived class can also access that, yet provided there is some restriction. Okay, okay, and then but non-members cannot access the protected. Okay, so similarly, under private, members, only members of the same class can have access to the private mode. Okay, but the derived class cannot have any access, and non-members also cannot have any access. Okay, so try to understand this table. Okay, and then compare that with the programs that I have just taught you. Okay, so now let's move on to the next slide. So here the same program, okay, I've made some changes, as you will see. Okay, so you can type this program also and you can check out. Okay, so in here the same program, you'll see that uh, I have changed the access specifier, the public, right, public in with height. Now even if you write down as protected also, okay, it won't matter much. Okay, public and protected in this case works almost the same here. Okay, so under most of the condition, protected x more like private. Okay, so here you will see in this program uh, some new addition, that is the constructor. Okay, so even if the constructor was not written in the previous program, okay, the program runs successfully, and when you type these constructors also, the program will run successfully. This is just to show that, okay, even if the constructor is not typed out, okay, explicitly mentioned, okay, when the program is run, the constructor will be invoked automatically. Okay, so I'll just read out the uh, sentence part. Once the object is declared, okay, this declared, storage is allocated to the object. As you know that when the class declare the object, okay, storage will be allocated to the object, okay, members. So constructor initialize the values of to the object members. Okay, so the constructor's purpose is to ensure that proper initialization of the object members takes place. That is, if you do not initialize the object and you run the program, and let's say the cout statement has access to the object members, but no values has been assigned, then the program will give garbage values, which is non-acceptable. Okay, so constructor will initialize, okay, to the default value, that is 0, and in terms of string values it will be null. Okay, so here always the base class constructor will be initialized first. Always keep in mind that, okay, the base class constructor will be initialized first because it is at the topmost. Okay, and then the derived class constructor gets initialized one by one. Okay, so every class constructor is initialized only once. All the class constructors will be initialized once, so that to ensure that all the class members gets properly initialized. Okay, so here you'll see that C polygon, right, that is the default constructor. Okay, as you know that the constructor name is the same as the class name, it does not have any return type. Okay, so as you can see within the curly brackets, no statements are written, right? So since no value has been assigned, okay, so the default constructor will assign the value 0, will initialize the value 0. Okay, or in that case, this default constructor gets invoked, okay, and then it ensures that proper initialization of the objects takes place. Similarly, under the second class, you can see that, okay, C rectangle within the C rectangle column, C polygon, okay, and then there's a blank statement. The body of that particular constructor is blank. Okay, similarly down below again you will see the C triangle colon C polygon, again blank statement. Okay, so this ensures that the members of the class are initialized properly. Okay, so it sets the value to the default value, that is 0. Okay, but when this constructor gets invoked, okay, what will happen is that first you will see that the base class, the base class is uh, always written, the body of the base class is also written in the derived class. Okay, which is linking it with the derived class actually. Okay, that is C rectangle colon C polygon. Okay, so that is linked with the base class constructor is linked with the derived class constructor. Okay, so when it get executed, okay, first the base class constructor will be called and then it will be uh, executed. Okay, and then after that only the derived class constructors will get initialized one by one. Okay, so this is how you execute the program, okay, using the constructors. Okay, so I hope that with this program you have understood the concept of the private public protected access specifiers and then the use of constructors. Okay, if you have not understood how this constructor works, okay, I suggest you go back to the constructor chapters, okay, and check out on the default constructor, parameterized constructor, and copy constructors, all those things. Okay, so that will be for today. Yeah? Okay.